Good afternoon. My name is Chad Ross, and I'm the Manager of Industry Relations and Total Store Collaborations here at the Food Marketing Institute, or FMI. FMI is pleased to welcome you to today's webinar, sponsored by IFCO. Just some quick housekeeping. Be sure to enable your computer's audio or speakers with the volume turned up. Also, at the end of this presentation, our presenters will be answering questions you submitted through the chat function. Today's program is the final segment in our three-part series sponsored by IFCO entitled Remove the Risk, using data to drive fresh produce growth. Today we'll learn the bottom line. Fact-based decision-making drives fresh produce supply chain savings. A fascinating look at potential supply chain savings in today's business environment. Speaking today, we have Hillary Femal, Vice President of Global Marketing from IFCO, and Dr. Jay Singh, Packaging Program Director from Cal Poly.
Thanks. This webinar will explore research relating to the packaging value chain, which is a concept developed by Dr. Singh of Cal Poly State University, and which looks at the impact of packaging from a holistic standpoint, from consumer experience to sustainability to cost. But specifically, this research we'll review today focused on a holistic costing approach to help better understand the financial impact of packaging within the fresh produce supply chain. The research also looks at produce damage, which is one of the biggest contributors to costs. Finally, Dr. Singh will show us the calculation tool that he and his team developed based on this research, which helps to quantify these impacts and enable fact-based packaging decisions. But before we begin, I'd like to show you a short video which introduces our company, IFCO, to you and to explain our product, Reusable Plastic Containers, or RPCs, and the reuse model within the fresh produce supply chain.
At IFCO, improving efficiency for our customer supply chain is the goal. From transportation to labor to materials, we know our customers' businesses inside and out, and we make sure you will always have what you need when and where you need it. As a company committed to environmental sustainability, our solutions reduce natural resources and energy consumption while also reducing waste and greenhouse gas emissions. IFCO RPCs make for the ideal produce packaging solutions, reducing supply chain costs while delivering superior quality produce. Using efficient logistics, IFCO helps to minimize the need to carry an inventory of RPCs. Reducing cost and seamlessly integrating into existing packaging operations, our RPC cycle begins when IFCO delivers clean RPCs to leading growers and shippers when and where they're needed. Once packed with produce, the RPCs are loaded onto outbound trailers destined for grocery distribution centers. IFCO's RPCs maximize the use of trailer space through efficient stacking, which also better protects produce while in transit. The rigid construction supports weight to eliminate crushing, and ventilation reduces heat retention. At the distribution center, the innovative design of the RPCs make for easy product identification. The ergonomic handles reduce injuries, while their sturdy construction creates strong mixed pallets that hold up perfectly in the wet room environment. Over 85% of produce managers surveyed noted that they preferred RPCs to corrugated boxes. Once arrived at the grocery store, RPCs can be used for both display and restocking and can easily be returned to IFCO after use. The process is simple and seamless. Back at IFCO's AIB-certified service centers, RPCs are then inspected, cleaned, dried, and shipped back to growers to begin the cycle again. IFCO customer service is available night and day to deliver the very best assistance to our valued customers. IFCO provides cost-effective, efficient, and environmentally responsible reusable transport packaging solutions to the world's most successful retailer manufacturers and growers. IFCO Systems is your global partner in reusable packaging solutions.
As you saw in the video, RPCs touch all nodes of the fresh produce supply chain because they're used for packing, cooling, shipping, handling, and often display as well. And of course, there are costs associated with each of these nodes and activities. Now, in traditional simplistic costing models, only acquisition costs or price are considered. As Dr. Singh will elaborate, retailers are increasingly using more sophisticated costing models, which take into account all the activities that results in cost inputs. So why the change? Well, the simplified approach can actually be very costly. In fact, research performed by the Fraunhofer Institute for Material Flow and Logistics in Germany quantified these indirect costs at up to 85% of the total packaging-related costs in the fresh produce supply chain. So if we know all that, why bother undertaking such extensive research as we've done with Cal Poly? Well, the problem is, even though everyone knows these costs are out there, they're very difficult to quantify. Many of these costs are buried within the P&L and are very hard to isolate. Even more intangible is the cost benefit of standardization. It's well accepted that standardization in general drives greater cost efficiencies and savings across all industries and applications, but isolating and quantifying this benefit is very difficult because it impacts so many different areas. So this research performed by Cal Poly took more than a year, and the development of the calculator tool took even longer once that research was completed. This was no small task, but we were committed to finding useful data and developing useful tools that retailers in particular could use to help quantify those hidden costs. So with that, I will hand it over to Dr. Singh to present his team's research.
Thanks for the introduction, Hilary. Direct costs are indeed tip of the iceberg in terms of the overall impact. I'm going to start my presentation. The topic, as you can see on the screen here, is analysis of the impact of packaging on the indirect costs in the retail fresh produce supply chain. And I'm speaking on behalf of the team that also includes Dr. Koushik Saha here at Cal Poly. My name again is Dr. Jay Singh. So before we get into the topic, I would like to give a little bit of background on the Cal Poly packaging program. As some of you may know, it's situated in San Luis Obispo, California, central coast of California. And it is considered among the leading education and research programs on the West Coast. Matter of fact, west of Mississippi River, we are the lead program. Our Learn by Doing educational focus, which is also the mantra for Cal Poly, is true to everything we do in terms of imparting education to our undergrad and graduate students. And with the true emphasis on packaging value chain, which got us into the ranking, number one ranking in the country by Value Colleges recently, our scope goes beyond just packaging science and technology and incorporates technology in terms of manufacturing, production, design elements, and also overlaps with business elements, marketing being one of them. We do have consistently evolving best-in-class laboratories with new addition to our team member, the core team packaging educators and researchers. We are consistently evolving our labs and including more research and education-based equipment in our labs. We have a growing portfolio of funded research. We have been very successful in undertaking state, federal, as well as privately funded proprietary projects from the packaging industry. And we do have also emergent industry outreach portfolio where we put on workshops or seminars for the industry to be better educated on the latest developments in the packaging industry. Cal Poly's packaging value chain program, both at undergraduate and graduate degree level, basically has one statement. We claim to be undisputed leader in experiential packaging education and technology by providing the global packaging value chain with premier talent and applied research. Being successful in the educational realm, we do require a lot of support and partnerships with industry groups and organizations, including some public or privately owned companies. On the screen, the logos of many of them. Most of them either provide us gift in kind of options where we get materials for research and education, or we get equipment-based support, either donations or refurbishments or maintenance. And we also have generous contributors who provide us with guest speakers or any special requests we may have. In 2008, we also launched a consortium for packaging research, which had a focus on, and still does have a focus on, post-harvest packaging and handling. It was essentially launched to provide our membership leadership amongst the peer companies by keeping to the forefront on current and future issues related to fresh produce supply chains. Some of the key focus areas that we have covered in the consortium are packaging forensics, safety, design, sustainability, etc. Currently, we are in our 9th year of operation. We typically have between 12 to 15 industry partners. You can see the membership for this past year, which we are concluding this month. And about 4 to 6 annual projects are done based on the budget and the number of members we have, as well as the priority of the member organizations. Coming back to the focus of this presentation, the packaging cost impact study, there were 2 pieces to the study: observation of process times, as well as product damage, and then modeling the cost impact through these observations. Activities were observed and process times were collected by Cal Poly personnel, which included myself, Dr. Saha, as well as some student assistants. And these observations were made at retail stores, distribution centers, and asset recovery centers for these retailers. There were 2 North American retailers, 1 national and 1 regional. The product damage was also quantified at the distribution centers and store levels, and on the screen you can see the supply chain, the channels that we monitored. Observations, as you can see on the screen, were made at the distribution center, at retail, and asset recovery centers. The research objective of our study was to quantify and model indirect packaging-related costs for the North American grocery, retail, fresh produce supply chain. And the methodologies as stated up here, as already stated, we had 2 retail supply chains that we observed, 1 national, 1 regional. We observed activities and packaging in distribution centers, retail stores, as well as asset recovery centers. We ended up using a time-driven activity-based costing method, which is a activity-based costing method that is driven on a base time to assess all resources by their effective usage. Packaging damage rates for uniform and mixed loads of packaging types were observed at distribution centers and retail stores. Percentage of RPCs present in the given mix pallet, which is essentially at the fulfillment of orders at the distribution center for retailers, was noted and later used to investigate the correlation between level of standardization of packaging and damage rate. Almost 4,000 packaging units. These were bulk packages, either single use or multiple use, like the reusable plastic containers. On this slide, we provide a perspective of how bulk packaged commodities are moved from grower to distribution centers to retail stores, and ultimately the empty containers are sent for disposal or sorting at the asset recovery center, which are typically located on site at the distribution center in a different building or located close by. We were not able to include the grower phase into the observations. It was omitted primarily because of the high variability in grower operations based on commodity and seasons, etc. But we do account for shipping distances from grower to the DC in our model. All right, so first let's look at the activity-based costing portion of this research. We observed activities at both the distribution centers and stores, as I previously stated. At the DCs, we categorized the activities into the following as reflected in this graph, on this image here on the slide. So I'll walk you through these 7 activities that we broke down for the DC operations. Incoming trucks are unloaded. These are typically full pallet loads of commodities in bulk containers, which happen to be occasionally of a taller height than is the DC warehouse or the DC storage space is able to accommodate. So they are broken down in terms of taking off a few tiers and reassembling them. Once these pallets are broken down and stretch wrapped again, these are then taken into inventory, assigned a unique identifier, and then slotted, which relates to placing these in the warehouse, in the storage space, per their needs in terms of temperature, humidity, or moisture. After they've been slotted, almost immediately after, a second shift comes in, or second crew comes in that basically focuses on order picking. These are orders that have been placed by retailers serviced by the distribution center. And these order pickers go around and pick up bulk packages, place them on a pallet, and create a mixed pallet load. The mixed portion there essentially relates to all kinds of commodities and packaging types are placed on the same pallet, and then they are secured using minimal stretch wrapping. And once that is accomplished, they are then loaded onto an outbound truck trailer out to service the retail stores from that distribution center. So this slide walks us through three of the activities at the distribution center operations. The unloading, with regards to unloading, it relates to the time required to pick a pallet load from within the truck trailer and bringing it at the tip or right outside the truck trailer. We observed no statistically significant difference. Primary reason being most of these or all of these pallet loads arriving at the distribution center are very neatly packed. They are the same footprint, same material, same design for all packages on every pallet load. So it's pretty neatly packed and easy to remove from the truck trailer, hence no significant difference there. Breaking down of the pallet relates to, again, as I stated in the previous slide, breaking down the pallet load to be easy to store in the storage spaces within the distribution center. So essentially removing a certain number of tiers to make the pallet height short enough or optimum enough to be loaded in the storage space within the distribution center. RPCs lend themselves relatively well in comparison to one-way packages because of their standard footprint and easiness features, whereas the single-use packages, we observed not all, but quite a few of them had additional tertiary packaging like corner boards and straps that needed to be taken care of prior to breaking down the pallet. The next activity is related to taking into inventory. This relates to the pallet load that has been broken down to be prepared for slotting, which is the next activity. So this is where you essentially have a stretch-wrapped, optimum dimensioned pallet load that now needs to be given a unique label so that it's easy to pick it later. Moving on to the next slide. Next is slotting. Slotting, you can see for all the remaining four processes that we observed at the distribution centers, slotting, auto picking, and palletizing, stretch wrapping these mixed pallet loads, and then loading them to outbound truck trailers that would bring them to retail stores. Across the board, we had anywhere from 9% faster rate for slotting to 50% faster rate for auto picking and palletizing. I would like to point out the auto picking and palletizing process was faster essentially because the standardized footprint allows the picker to select products in any order, and they can be seated on that mixed pallet load fairly easily because of the standard footprint. Stretch wrapping, because a majority RPC driven mixed pallet load had more stability and uniformity, it was quicker to hand stretch wrap these mixed pallet loads, and that's what they do at the retailers we observed. As far as loading the RPCs, into the outbound truck trailers for point of sale or retail store locations, RPCs, majority RPC based mixed pallet loads were observed to be more stable and uniform. and hence their movement was faster because additional precautions did not need to be taken. So to conclude, as related to the DC operations, we saw higher level of RPC use in the DC, resulting in greater handling efficiencies. Retailers with a higher RPC usage rate realized greater handling efficiencies even with the same commodities. And RPCs reduce the need for specialized handling expertise because of the standard footprint, the interlocking design of the RPCs, and handholds that make highly variable processes consistent. So on this slide is a breakdown of the activities during the retail store operations or point of sale operations. Let me walk you through these 8 activities, starting with unloading of the truck. This is where a mixed pallet load shipped from the distribution center is brought out of the truck trailer, and then it is stocked. Stocked is where these mixed pallet loads are broken down, and each type of commodity is placed in a designated space within the back room, which has a refrigerated space. Then comes the auto picking component or activity, where the personnel in the fresh produce department using carts pick different commodities or the bulk packages, place them on these carts and bring them out to the retail store floor. So that's the next activity, transporting these loaded carts to the retail store floor, essentially getting them close enough to the retail store shelf. Where the commodities are taken out, the 2 retailers we observed did not take advantage of the single touch aspect of these bulk packages, where it could literally be taken off the pallet load or the bulk container could simply be placed on the retail store shelf. So what we observed at the 2 retailers was hand stacking, where they would pull out the commodities individually and place them on the retail store shelves. Once that had been achieved, you're left with empty containers, which are now brought back to the storage space right outside of it, where depending on the type of container, it is either placed in a baler, which is for single-use corrugated containers, or it is folded and in the knockdown manner for RPCs and stacked on a designated pallet in a designated space in the back room. Once the bales and pallet loads of knockdown RPCs are ready to be picked up, they are loaded with this onto the same delivery truck that brought in the mixed pallet loads, and then brought back to the asset recovery center, where they are then put through their own set of activities. I'll go over some of the results on these individual activities that we observed at the retail stores. In terms of unloading, there was no statistically significant difference in timing. In terms of stocking, RPCs had a slight advantage, about 5%. Majority of the RPC pallet, the mixed pallet load with the majority RPCs were relatively easier to break down. And what happens during stocking is they break down the mixed pallet load and stock them in designated spaces within the back room, which is refrigerated. And also the contents were easy to identify with clear labels in the same place for all packages, which is very common with RPCs, whereas one-way packages come in a variety of shapes and identifying labels that are not placed in the consistent same location. In terms of auto picking, the RPCs were faster by about 53%, and then we basically associate this with the RPCs being rigid, ergonomic, standardized, and stackable. So picking becomes fairly simplified as compared to some of the other one-way shippers. Moving on to transport to shelf, as previously mentioned, this is typically where these bulk packages of all types are placed on a cart that is filled in the back room and then brought out to the shelf on the retail store floor in the produce department. So RPCs were slightly faster again, and we contributed that to them being easily identifiable, easier to handle, and the stability of RPCs being standardized packaging design allows them to secure movement to shelf area. Transport to back of the empty containers, we did not see any statistically significant difference. In terms of folding and baling, folding and stacking for RPCs and baling for corrugated containers, they were almost at par. RPCs were faster by about 6%. Baling takes a substantial amount of time, but when you look at the number of containers that are in a bale per container time, it's fairly comparable to RPC knockdown and stacking time. The one-way containers go through loading, compacting, and baling cycles, and they have to wait till they have a preset level of boxes in that baler before they can finish the baling process and get them ready to be picked up. RPCs, on the other hand, as soon as they get back, they are knocked down and placed on a designated pallet, and they become fairly easy to move past that. In terms of loading, these RPC pallets are baled one-way packages. There was no statistically significant difference that we observed. So in conclusion, for the retail store activities, RPCs reduce the need for specialized handling expertise. You do not have they have a common footprint. They are very standardized. You either have them in the full footprint or half footprint. So the standardized footprint, interlocking design, the handholds, which are fairly ergonomical, make for highly variable processes, very consistent. And we're talking about all kinds of commodities that are placed in these limited standardized containers. RPCs are also more space efficient. They do not bulge. They can both be packed and emptied. When they are both packed and empty, they are very space efficient, helping better utilize limited space in the back room and on the carts that are bringing these bulk packages onto the retail store floor for loading onto the shelf. And the last activity that we observed, the last location or operation that we observed, was related to the asset recovery. Most all retail stores have their own asset recovery centers, which typically ends up being at the same distribution center location, but a different building. So in terms of asset recovery activities, we basically had three primary activities: unloading the truck, physical reception of containers, which is bringing it to a set location for any rearrangement or prep that might be needed, and then sorting and securing. So if there is some element in that bale or in an RPC, knockdown RPC pallet load that needs to be fixed, that is what is done at this point. If needed, they are stretch wrapped again. So in terms of asset recovery center operations, the three main operations are here on the screen. Unloading, we observed RPCs to be faster because they are fairly cubed. They are more stable. RPC pallet loads could be moved out of the trailer easier and quicker because there's no, it's a cube. You do not have the bales essentially bulge out, and though they are meant to be of about the same external dimensions, they typically require a little more careful handling. Physical reception of containers, there was no statistically significant difference that we observed. Sorting and securing, this is where we observed the asset recovery center personnel would take a second look at the bales or the RPC pallet loads of the knockdown RPCs to see if they needed any improvement. So if a baling wire was broken, you need to rebale it. If RPC had opened up and was not secured properly, that would be done at this point. So overall, we saw RPCs being handled much faster because they are easily secured and stretch wrapped for further shipment. Whereas bale loads, we had occasional bale load where it needed to be rebaled due to broken straps or wires that are used to hold it in place. So in terms of Asset Recovery Center, here are our conclusions. Used folded RPCs are much easier to handle. They are also easier to stretch wrap, etc. And all essentially because they have a uniform footprint and an interlocking design, so they nest well, they engage well, and they do not slide around. Baled cardboard or corrugated fiberboard were shaped inconsistently. They would have occasionally, like I said prior, the outer external dimensions of the bales were not extremely consistent to each other. Straps or wires on bales broke frequently and require restrapping. So after the time-driven activity-based observations, we move on to the damage rate observations. As is commonsensical, the physical and ambient environment-related abuse of packaged fresh produce in the supply chain can influence the damage levels for the products carried within. So to assess the damage rate for RPCs and single-way or single-use shippers, we made observations at the distribution centers as well as the retail stores. As you can see in this flowchart, what's shown here are some types of damage that we observed and potentially the cause for these damage. So on the left-hand side is damage, we'll call this externally influenced or damage due to external influence, not due to design or material or any other reason, but because of external influence, which I'll expand on in the upcoming slides. And below the store operations is an image of a typical mixed pallet load. This is a majority single-use packaging based mixed pallet load. You can see an RPC on the top there, but a majority of the containers on this mixed pallet load are corrugated. And you can also see one of the main reasons we saw damage of varying types on the packages was the non-standardized footprint. You can see on the bottom left of this image how packages are having a difficult time engaging or sitting on top of each other and thereby causing damage to each other as well. So this is a typical mixed pallet load, very minimal hand stretch wrap. You can see maybe 3 or 4 layers of stretch wrap placed on it. So this is how this mixed pallet load is prepared and now is ready to be shipped over to the retail store. So this slide walks you through the packaging damage rates as observed at the distribution centers. As I mentioned before, we'll get into the damage types on the next slide, but these are observations based on one-way bulk packages and RPCs that we observed. So for one-way packages, we observed 1,190 individual cases that were inspected, of which 27 cases were damaged. So that brings our percentage at 2.27% for one-way packaging. Whereas for RPCs, we observed 663 RPCs, and one of them was damaged. That brings the RPC packaging damage rate at 0.15%. Containers were observed throughout the distribution center for physical damage, and damage was considered when a container had lost structural integrity or could no longer be considered functional. Various causes associated with this were observed and are noted on the next slide, as I stated prior. The causes of damage, as I stated prior, were broken down into three categories for one-way as well as RPCs. Our observations, we broke it down into three categories. Structural strength. This is where a material is not adequate in strength, or the design is not adequate for the purpose. So we had about 41% of the damage observed on one-way packaging due to the structural strength. Securement also becomes an issue because of tabs that don't line up, or as you can see in this top right picture, the trays are supposed to nest in each other, but they end up, the tabs either get broken or not aligned properly, and the bottom of the top tray then end up sitting on the product in the tray below. So this is 22% of one-way packaging was observed to be damaged due to securement issues. And of course, there are things that are out of control. These are activity-based damage that can be caused on not only one-way packages but RPCs as well. Where on the bottom right, you can see this image where a forklift truck or a pallet jack went in too far when unloading or loading these containers or placing it in the storage space in the distribution center. So you can see that bottom right container has moved back considerably. The pallet board, top board, has been broken or damaged as well. With regards to RPCs, the damaged RPCs we saw always were due to someone not locking the RPCs correctly or stacking it correctly, but never due to the structural integrity or bad design of the RPCs themselves. So standardize is in play here. One structurally unsound package on a pallet can cause the entire stack to fail and or damage the product. And there's too much variation in corrugated fiberboard box designs and materials themselves, and that problem, as reflected in this observation, was solved through RPCs. The only one package that RPC that we saw damaged through our 600 plus observations was due to an external influence. As you can tell, you can see the white portion formed at the bottom right corner of this RPC. That's where a forklift impacted this RPC, thereby knocking one of the panels out. You can see the product inside. We'll discuss the product damage later, but this was the one RPC that we observed to be damaged, but the product inside was still intact. Overall, the product damage, we observed the two retailers that we had the opportunity to visit. They both had excellent quality control. Both of them, on average, inspect about 2% of all product coming in for each pallet load that they receive. And we broadly categorized damage rates as no damage, partly damaged, or completely damaged. We did not find any of the product, and this is again, we're talking about product that's stored at the distribution center after it's been received. We did not observe any that was completely damaged, both for one-way or RPCs, but we did get partial damage after it had been stored and internal handling had taken place, such as the pictures I showed you prior on packaging damage. Those end up damaging the product inside as well. So for one-way packages, we observed about 8.6% damage, whereas a product that was inspected inside RPCs at the DC, we saw none. This slide provides the observation results for packaging damage in terms of observations that took place at the retail locations. For one-way packages, we observed 1,647 individual cases, and of which 13 were classified under the damage per our definition, and that relates to about 2%, 1.9% of all one-way packages that we observed were found to be damaged. As related to RPCs, we found no damage to amongst the 444 RPCs that we inspected. The causes for damage at retail, as related to the one-way packaging, again broken down into structural strength, securement, or external influence. We have some images here. There was no damage due to external influence because the volumes of mixed pallet loads coming to retail stores are substantially lower than those being observed at distribution centers, as well as the related handling is much less severe. So majority of the damage we observed was caused due to structural strength, again improper use of material or the design of the bulk package, and about 26% due to securement. And you can see some of the packages, some of the bulk boxes here almost slipping off the load because of substandard or non-standard dimensions of these one-way packages. So overall, the product damage, again, this was partly damaged product observed at retail for one-way packaging was about 10.5%, whereas for RPCs we observed none. Interesting fact here, we talked to these fresh produce managers. A typical retail store has anywhere upwards of 5% as shrink or fresh produce that they're not able to sell. That's actually detailed by every shift and every fresh produce manager. But the interesting thing here was if it is partly damaged, the fresh produce managers typically reassign it to the deli that is in the retail store, or occasionally they will improve the product by, so for example, if it is lettuce, peeling off some of the outer leaves and placing it on sale or on some discounted price or as a special. The total packaging damage, which I went over prior, you can see from this graph overall between activities at distribution centers and retail stores, they add up to 4.15% for one-way packaging, and in terms of RPCs, it's about 0.15%. So to summarize the impact of damage, as we stated prior, we observed about 1,190 one-way shippers made out of corrugate at the distribution center, about 1,647 cases at the store, for a total of about 2,837 total corrugated fiberboard boxes that we observed. Of these, about 58 were in total were damaged to varying degrees, and upon inspecting the produce contained within these 58 damaged boxes, we observed at least partial damage to the product. So out of about 2,837 total corrugated boxes, 6 contained product with damage. That results in about a 0.21% damage rate of all corrugated cases containing produce due to packaging. So this may not seem like a big deal. After all, it's less than 0.25% of cases of produce damage. But what if we assumed a $20 per case cost, about 30 million cases per year being moved through the supply chain for this commodity or this produce category? And we then include this less than 0.25% of damage. Back of the envelope calculations will tell you it's a little over $1.2 million of damage. So we've gone through quite a few observations that we made, not only based on the time for different activities at the distribution centers, retail, and asset recovery center, but we also included some damage-related observations for product and packaging. So all of that information was included in the development of a costing tool that quantified the cost impact of each activity in the supply chain and combined it into one model. Development of the tool to model costs was based on retailer-specific inputs. In other words, the tool that we developed is customizable to a particular retailer's operations and activities. And the tool was created to help calculate the cost impact of RPCs across their fresh produce supply chain. Retailers are able to specify their own data and the product setup, as well as compare different degrees of standardization via current and potential RPC usage rate scenarios. And it'll become clear as we discuss further. So the tool that we helped create is now trademarked as freshIMPACT. It's an RPC packaging cost evaluation tool. So within the freshIMPACT tool, the costs that are included are packaging costs, which is a user entry. It can be customized per each package type that is being used. Transportation costs towards calculations based on user supply chain. Space utilization, so calculation based on, again, user space costs. Labor based on time trial results, how much time it takes for each activity, as well as users' labor costs. Equipment usage, it's based on time trial results again, and the user equipment cost. And product damage, we created a predictive formula based on the RPC usage rate that we briefly touched on in the prior slide. So this is a screenshot of the freshIMPACT tool where a retailer can customize the tool per their requirements. The retailer-specific costs are entered into the tool for both distribution center as well as the retail stores, and includes product sourcing, personnel, warehouse space, loading specification, transport equipment, etc. As well as you can see on the very bottom here, the product damage estimates at retail. This is another screenshot of one of the two areas of the tool where retailers input their specific parameters. So you can enter, the retailer is allowed to enter the current produce damage rate, let's say it's 2%, and then it also allows them to break it down by category of what they do with what action is taken with the damaged produce. So in this case, we have broken it down almost evenly between disposing, it's not good enough quality to be sold or transferred. Discounting is where you sell it at a discounted rate, and transfer is within a retail store. So for example, transferring it to deli for some fresh salad that they might be making there. And in terms of percentage of the product value lost, you can customize this again. If you're disposing, it's 100% loss, and in the discount, what is the percentage of product value lost? So you're selling it at a 10% discount, or when you transfer, again, you write it off by about 10% of the value when you are transferring it within the store. So this is where the screenshot shows the results or the output from that tool generated on the customizable data input. It calculates the relevant cost for each link in the supply chain. So you got a breakdown here between DC, retail, transport, and product damage, what the associated costs would be. And it also provides, if you note on the bottom of the two bars on the x-axis, you can have a current situation, which is, in this case, is showing you have a 25% RPC usage rate. And on the right is the costs associated with 80% penetration of RPCs or usage of RPCs in this retailer's supply chain.
Thank you so much for taking us through that, Jay. As Cal Poly's research clearly shows, packaging impacts costs in a variety of areas throughout the supply chain. Not only are RPCs designed to speed various handling activities and dramatically reduce product damage, but when used to standardize an entire distribution system, RPCs offer additional cost reduction beyond the per case savings. And because all these indirect costs add up to such a significant share, up to 85%, of all packaging-related costs, it's critical to take them into account when making packaging decisions. And now, thanks to Dr. Singh's research, the tool his team has developed for IFCO offers retailers a way to quantify these hidden direct costs. Interested retailers can simply reach out to me or any other IFCO representative for a freshIMPACT analysis. Or if you'd like more details on the process, materials are available at blog.ifco.com. Okay, so with that, we will open it up for the questions which have come through via the chat function. Thanks for those. I'll just read these out loud. We probably have time for 4 or so, and I'll answer any that pertain to IFCO, and Jay, if you don't mind answering any that are about the research specifically. Okay, so let's start with this first question. It was mentioned that 85% of the total cost is indirect. Where did this number come from? So I can answer that question. This figure comes from research which was performed by the Fraunhofer Institute for Material Handling and Logistics, and they're based in Munich, Germany. And this research began back in 1994. And has continued to this day. Various studies have been conducted with different retailers across Europe since then, just sort of building to the body of data. And then in 2006, IFCO commissioned Fraunhofer to turn some of that research into a calculation tool, very similar to the freshIMPACT tool. And results from various scenarios that have been run through that tool for different retailers over the years show that it's upwards of 85% of that total cost is actually indirect. Okay, so now the second question, I think this one will be for you, Jay. What is the per case savings that is calculated by switching to RPCs?
Well, that depends on a variety of factors, of course, and not the least of which is the percent RPC use in supply chain. In other words, if 20% of your cases are in RPCs, you'll save less per case than if, let's say, 80% are in RPCs due to the standardization effect. However, in the various scenarios we have run in North America, savings of up to $1 per case have been identified. This does not include any difference in the packaging cost itself or any cost savings if you use a single touch display with RPCs, as not all North American retailers display in RPCs, so that figure is even conservative.
All right, thank you. Next question. Will the tool measure my supply chain costs exactly?
No, the tool is not intended to illustrate the cost impact related to packaging across the supply chain at the various degrees of standardization. Cost impacts of a sensitive nature, such as injuries or those resulting in workers' compensation claims, were not included.
All right, and this last question is also for you, Jay. Will I be able to see what the cost impact is for a single commodity?
The tool is not designed to show the cost impact of a single commodity because the processes quantified cannot be isolated to one particular or single commodity, and because such an approach cannot account for the overall effect of standardization across many commodities, which is fairly substantial.
All right. Well, thank you very much, Jay, and thank you all for your questions. This now concludes our 3-part webinar series, Remove the Risk, Using Data to Drive Fresh Produce Growth. I'd like to thank you all for joining us this afternoon. We hope you've enjoyed this last webinar, and we encourage you to reach out to myself, Femal, with any additional questions in the future. So thanks very much.